There we go. All right, so what I want to do is go through this with everyone. But again, what I did was I used the box grid method. Same. I think I called it. I think I called it both. But again, either method you can use. So let me let me do this. Okay, so let me see if I can zoom in. You're not. There we go. Get better. Made it worse. All right. Okay. If you can't see something, like if it's blocked off, just let me know. Okay, I can always zoom out. Let me do that. There we go. Okay. All right. So for the first product here, they both have, as you can see, the same number of terms. I'll post this also on on Blackboard as well. But you can see they both have the same number of terms. So what I did was I chose the second one to make my rows. The first one I chose to make my columns. I mean, that was kind of random, I guess. But what you will get is you'll get a grid that looks something like this. And again, to get the entries in here, you just have to multiply the row and column term. So here, right, you'll have the row times the column term. That gives you this. X cubed times 4x gives you 4x to the 4. X cubed times 3 gives you 3x cubed. Okay. 5x squared times x squared gives you 5x to the 4. 5x squared times 4x gives you 20x cubed. 5x squared times 3 gives you 15x squared. Keep on going. 2 times x squared is 2x squared. 2 times 4x is 8x. If I go too fast, just let me know. I won't get upset. 2 times 3 is 6. So now that we have these entries, right, what do? Well, we have to add them. That's how we get the product. We have x to the 5th. Sometimes you can look around a bit to see like which term would come next, because we want to write it in standard form. We do have 5x to the 4 and 4x to the 4, as you can see. Let me do this. There we go. We do have 5x to the 4 and 4x to the 4. Okay. Let's write those next to each other because those are like terms. Next, we have 20x cubed. We have 3x cubed. We write those. We have 2x squared, but that's not a like term with x cubed at all, with either one of these x cubed terms. So we'll write that. We'll not write that. Well, we can write that now, actually, because there's no more x cubed terms. See, we do have 15x squared. Let's write that next. 8x, then 6. Now we just combine, right, the like terms. 5x to the 4 and 4x to the 4. That's 9x to the 4, right? Remember, when you add, you don't change the exponent, okay? You don't do that. With 20x cubed and 3x cubed, right? We have 23x cubed, as you can see, okay? We have 2x squared and 15x squared. That's 17x squared. We have 8x, and we have 6. Okay? That's what we get here. Good. So this is what we get here. Okay, that's good. That's for the first one. Okay, now let's move on to the second one. Okay, so now we have this. So we have these two to multiply. I know this grid's going to be a little bit bigger, as we can tell. So this is the one with a smaller number of terms. Okay. We have x cubed. We have minus x squared. So I'm using the first one. Each term gives us a row. For the longer one here, each term is giving us a column. And then, just like before, you multiply, right? You have x cubed times x to the 4. That's x to the 7. Okay. X cubed times 7x squared, right? That's 7x to the 5th. You keep on going. X cubed times minus x to the 4. X cubed times x cubed times minus 2 is minus 2x cubed. And you basically keep on doing this, you know, for minus x squared with each one, as you can see. Good. Because of the minuses, this becomes a plus, positive, I mean, right? Minus is a plus. 5x to the 4, 5x to the 4, right? Here we have 35x squared, and so on. And then just like before, we have to add them up, right? I know it's a lot of terms here, so, you know, that's okay. X to the 7, right? I mean, I could start going this way, but I see a minus x to the 6. So let me put that down next. Then let's go to the x to the 5th term. You know, sometimes you have to look around if you want to write it in standard form. See, we have 5x to the 4. See, we have up another x to the 4 term. Then we have another x to the 4 term, right? I think that's it. So next would be x cubed. We have one over here and this one. What about x squared? We have this term, we have this term, and I think that's it. We have minus 5x minus 10 as well. What you could do, I didn't do this, but you could actually cross off any term you use when you're writing out the product. So you don't write something more than once. I'm not saying you have to do that, but you could do that if you want. So we get x to the 7, minus x to the 6, 7x to the 5th, 5x to the 4, minus 7x to the 4, minus x to the 4. That looks like it's minus 3x to the 4. Next, x cubed minus 2x cubed. That's minus x cubed. 35x squared plus 2x squared is 37x squared. Then we have minus 5x, and we have minus 10. So that looks like the answer here. Are there any questions on this? Oh, sorry. Hope everyone can see that. I will post this on Blackboard later. So that one was a little long, but that's okay. Let me go to the next one. Okay, this one's not too bad either. Right, again, you know, it's the same process basically, right? We have, let me leave that here. We have, so I'm using the one with more terms for the columns. Okay, so we have 4x to the 4, 3x cubed, each term gets its own column, 9 to 9, 2x cubed is down here, minus 4 goes down here, as you can see. Then we multiply. So we have 2x cubed times 4x to the 4th, that gives us this. 2x cubed times 3x cubed is 6x to the 6th, right? When you multiply, that's when the exponent changes. 2x cubed times 9 is here. 18x cubed. Negative 4 times this is negative 16x to the 4. Negative 4 times this is minus 12x cubed. Finally, negative 4 times 9 is negative 36. I don't think, oh no, I was wrong. I was going to say that there are no like terms, but I'm wrong. These two are. Okay, so let's write them out. Here we have 8x to the 7, 6x to the 6. What's next? Okay, there's no x to the 5th term, but we have an x to the 4th term. Let's write that. We have an x cubed term. We have one here and here, so let's write them next to each other. And we have a constant term. And then we just combine like terms. It doesn't look like much we have to combine except the x cubed terms here. And when we do that, we get 6x cubed, and that's it. All right, that wasn't bad. Okay. So that's the worksheet. Okay, that was good. So what I'm going to do now is I'm going to start P4, which again is factoring. So let me get to that. I think if I remember correctly, I did send those notes, so should have those there. Let's see. Oh, here we go. All right. Good. Okay. Here come the factoring notes. I mean, factoring, unfortunately, is not, it's, you know, it's not easy. I'm not going to lie to you. Come on. Okay. trying to close something. All right, it's not. Okay. Wait, here, let me try one more time. Let me just close. All right, there we go. Wanted to close something. All right, so let's do factoring now. When you factor something, it's kind of like the opposite of multiplying, with polynomials, that is, in the sense that when you multiply two polynomials, right,